So in this video we're going to look at integration using substitution, and really when we talk about integration using substitution we're talking about a reversal of the chain rule. That's really why we do it. So if you can see that something's it's just reversing the chain rule that we used in differentiation, then you don't have to do substitution. Sometimes it's not as obvious and it's not as pretty. I'm going to use a few examples to show how we do this. So the first one here, you might be able to see that we've got e to the x cubed here, but if we have a look at the function out the front, 3x squared, then we can see that that's the derivative of x cubed. So if you're confident enough and you just go, well, I'm just going to reverse the chain rule and put that as e to the x cubed plus a constant of integration, then you don't have to use substitution. That takes a little bit of practice, but the more you do, the more you start to look and go, okay, that's the format you see. But if not, it's easy enough to use the substitution. So we're looking at the function of x cubed as replacing it with u, and so u would be equal to x cubed. Now, the way Alan does it, I do it a little bit different the way Alan does it. I really just look and say, look, let's take the derivative of both sides. So the derivative of u is 1 du. I don't put the 1 in. And the derivative of 3x squared, of x cubed, sorry, is 3x squared. But I also include, okay, what have I derived by? So I derived with respect to u on the left-hand side. I've derived with respect to x on the right-hand side. But what I'm looking to do is be able to replace the other terms, because I know I'm going to be able to replace the x cubed here with u, so that goes in there. But then I've got the 3x squared here and dx, and notice that the 3x squared and dx are going to be replaced by du. So that's where those two actually end up. So that's where I'm able to replace those with just du. And it's a nice enough question because it's the integral of e to the u is e to the u, so we've simplified it, plus our constant of integration, and u replaces x cubed, is replaced with x cubed. So the next question, the same thing, if you could notice the function there as a chain rule, the derivative as an application of the chain rule, then you can start to see that. But if you see, again, using the substitution of the more complicated function and putting it in, so du is equal to 6x plus 4 dx, and it just gets replaced. So you can see everything in this function is replaced to get a nice function there. One that I just wanted to highlight, it's a cute little one, is when you've got cos x sin x. Again, if we realise that the derivative of sin x is cos x, it works out nicely, but you could take u to be either sin x or cos x in this case. If you take it to be cos x, you'll get derivative being negative sin, so you just have to work with a negative in there. But you can see the replacements for both of those. So there's our du, and sin x is replaced with u, and it's just the derivative, and the integral becomes half sin squared x. Don't forget your constant. Alan will punish us if we don't put the constant in.